subtracting 3, another form of the equation of a linear relation. So there are 3 different types of linear relations, and we're going to start talking about all 3 different kinds. So the first one we're used to is one that has x and y both in the equation. So here's an equation with x and y, of course. We do not have a table of values to graph it, though. So we're going to build a table of values. What number should we always start with? 0. We should usually always start with 0. So 0, 1, 2. Okay? What is my next step? How do I find out what those y numbers are so I can plot my points? How am I going to try and do that? What's a strategy to use? Sure. Absolutely. So since we already have the equation, that beautiful little x sitting there, we're going to put all of those x digits in there. And that's going to solve us the y after we do bad maths. And we have to do them each separately. So a strategy to use for that, bless you, is to go 2 times the number, subtract 7 equals my y number. 2 times the number, subtract 7 equals a y number. 2 times something, subtract 7 equals a y number. That's your pattern. Right now, all of those x numbers are going to go sit in those brackets. So I'm going to use the 0, use the 1, and the 2. And that's going to find me my y numbers after I do the BEDMAS. So which part of the BEDMAS has to come first? The brackets that are multiplying or the subtracting part? The brackets always, okay? In this case, the brackets are indicating multiply. So we have to always do BEDMAS first. Multiplies before. So 2 times 0 is how big? 0. Good. That's just 0. 0 subtract 7 is? -7. Perfect. So that becomes a -7. Now we're going to find that point over here. So, did x go left or right at all? No. What does the -7 tell me to do, though? Down 7. Perfect. So go down 7 and put your point. There's my -7. Okay, that's my 0, -7. Next point. I take my 2 timesing by the 1. How much is 2 timesing 1? 2. Subtract 7. -5. Good. So that gives me a -5. Now I can plot that point. So remember, when I'm plotting points, I'm looking at the x number. And you always start at 0, 0 in the middle. So I'm going to look at the x. The +1 tells me to always go right if it's an x. If it's a negative, the x tells me to go left. But this is a positive x. So it tells me to go right 1 space. Then it tells me, what does the y tell me to do? Up or down? Down 5. The negative sign here means it's going to go down 5. Okay, so when I take a look at this spot here, I start at the middle as always. And I'm going to go right 1, down 5. And that's where I put my dots. Okay? That's how you find where to put your dots. Let's try the last one together. It says 2 times 2, subtracting 7. How big is 2 times 2? 4. Good. So I've got 4 subtracting 7. How big is that? Perfect. Now, if we take a look at the pattern in our y, what is actually happening to our y's? They're adding 2. They're going closer to 0. They're going closer to 0 as a negative number. They're adding digits. We're adding 2 every time. Okay? So do you notice, where does that 2 go? It went in front of our x variable. We know how to build the equations that way. We already have our equation. All right. We have one more last point to plot on our graph. 2 and -3. So I'm going to go right 2, down 3. And there's my plot, my point. Now, do I have a situation where it's going to describe to me whether or not I have to join the points? Does it tell me I have discrete or continuous data? No, there's no specific situation. If there's no specific situation, always join the points. So we're just going to join them points, okay? And you usually always put arrows on the end. The arrows on the end mean it's a continuous line going in opposite directions, okay? Any questions so far? Pretty simple stuff so far? Good question talking about whether or not, if you've got information on a graph, do you always have to join and put arrows on the ends? Now, a lot of programs computers do not put arrows on the ends of your lines. So you have to understand whether or not they stop or they continue. Now, a way to find that out is you take a look at the boundary of your graph. Here's the boundary of my graph. Okay? If this line here that I just drew, if this one here did not have an arrow at the end, okay, but one end went right to the edge of the border, and the other one did not. Well, if it's within the graph boundaries, and this one doesn't end, and they don't show an arrow, or sorry, it does end, but they don't show an arrow, that means it does end right there. Okay? If they would have connected it and said it continues on forever, it would have extended to the boundaries of the graph, to the edge of the graph. That's how you would know it would continue forever. If it doesn't and it stops somewhere in the middle, then that line had those two boundaries. It didn't continue. So they usually put little dots on the end. Sometimes they don't, again, because some of the computer programs don't do that in their graphing. So they could have a line doing this, and you're supposed to know that it starts here, stops here. Okay? How are you supposed to know that? Because it doesn't go to the edges of your graph. Okay? If it extended to the edges of your graph, then it would continue in both directions infinitely. Okay? But this red one here with the dots on the ends of it, I didn't put it to the edge of the graph. So that one would not extend infinitely. So if I were to draw it, I would not put arrows on that one. Okay? Whereas this one that goes to the edge of the graph like this, it would automatically have arrows even though the computer program didn't show it. Okay? Sure, you get questions on unit tests and on exams that have questions like this with graphs with no arrows. And you have to understand when they stop and when they don't. Okay? Is that pretty clear? So if it's within the boundaries and you see it stops, it stops. Okay? Alright, let's take a look at another example. We're going to graph a relation, but now we're not going to isolate the variable. Well, in the previous unit, we learned how to isolate variables. We learned that we want one variable on the left, the others, everything else goes to the right, correct? But we were only ever solving for x, or one variable. Now we're solving for two variables. So how do we solve for two variables? Well, if we look through the notes that I gave you, we've got the solving for two variable notes and isolating for two variables. So it says, if you have two variables x and y, when you graph it, the one that changes according to the other one, who changes according to the other one? Who's bossy? X is bossy. Okay, so who has to change according to the bossy one? The y does. So because we have y being told what to do by x, we're going to have y by itself and saying y equals everything that x ever does. Okay, does that make sense? Because y has to depend on what x does. So that's why whenever we have both equations, we always isolate the y. Okay? So when we isolate the y in this case, again, we're going to use zero pairs to move things across the equal sign. So if I want that y by himself, another hint is he has to have a hidden positive 1 in front. Okay? What do we notice is in front of this guy right now? A negative, right? He's got a negative, and there's a hiding 1 there. He's got a negative 1 there. In my final answer, when I solve him, and when I isolate the y, he can only have a hidden positive 1. So I need to get rid of that negative side eventually. Okay, but it's going to come last. So, we're going to get rid of the x. And we're going to take him to the other side, because we want y by himself. So we're going to take x to the right. How do we make the 2x a zero pair to move him? How do we make him a zero pair to move him sides? Yes, in the back. Divide by 2. If it was sitting side by side, absolutely you would. Okay? And we would do that if we only had one variable. Okay? But that's a step later. Lenise? Yeah, subtract 2. You're making a zero pair. Make it 0. Okay? When we multiply and divide, we're actually not making 0. We're creating a positive 1. Okay? I'll just show you what that actually means in a moment. So, make 0 pair there, so I need to do it to the other side. That keeps it balanced. So now I'm going to rewrite my equation. This gives me negative 1y equaling 7 subtracting 2x. Okay, 7 subtracting 2x. Now you would think that that's done. You would think that you're done, you've got y by himself. But remember, we want a hidden positive 1 in front of y. Right now, we've got a negative sign there. We've got to get rid of it. Now, we know how to do that from last unit. When things sit side by side, what's happening to y right now? He's being multiplied by what? Negative 1. So if he's being multiplied by negative 1, how do I get rid of that negative 1 then? You divide it. Good, you do the opposite. So, we're going to divide both sides by the hidden negative 1. That means if there's more than one thing on the right-hand side, we have to divide all of it by the negative 1. Okay, they're all dividing by the negative 1. Okay, because whatever you do to one side, you must do to the other side. So that isolates y for us. So we get y equals, what's 7 divided by a negative 1? Negative 7. What's a negative divided by a negative for 2? Positive 2x. Good. Now we've got our equation, and we can create a table of values to solve for our x and y values. Okay? So remember, we always pick a couple x values. So which x values would you like to choose this time? Negative 1, 0, and 1. Sound good? Okay. Negative 1, 0, and 1. We always have to put a 0 in there somewhere. Okay? Sometimes it's nice to start in the negative so we can see what happens to y. Alright, so we did the exact same thing we did last time. We take our equation and we write it out, substituting our numbers for x. So now I'm going to have negative 7 adding 2 times the number. Negative 7 adding 2 times the number. Negative 7 adding 2 times the number. Alright, now I'm going to put my x numbers in there. Negative 1, 0, and 1. Now I'm going to solve them doing BEDMAS. Okay? So let's solve those doing BEDMAS. I'll give you a minute to do that. Okay, here we go. We've got negative 7 plus negative 2 times 1. So it's negative 2 times 1, we get a negative 2. Plus negative 7 gives us a negative 9, you should have found. Over here, we should have found negative 7. And then negative 5. Okay, is what you should have got. So let's plot our points. Check your work. Did everybody get that? Yes. Nice work. Okay. So now we're going to go left 1, down 9. So left 1, down 9, I'm going to make my first point. Then, I don't go left or right, I stay on the line, and I'm just going to go down 7. So I'm not going left or right from the middle, I just go down 7. Okay, there's my down 7. Then it tells me to go 1 right and down 5. There we go. So again, am I going to join the points? Yep, because it didn't give me a problem-solving situation to tell me not to. So, you always join points and put an arrow in both directions. And hopefully you draw straighter than I do. So the question that is, what do we notice about the two graphs? What did you notice about the graph on the previous page and the graph of this one? What do you notice about them? They're the same, they're identical. Okay, they are the same in every way. And what does that tell us about those equations that graph those lines? The equations were the same. They didn't look the same to begin with. So what did that tell me to do? I don't get it. What does that say about the equations? Were they written the same way? No, they weren't. So, it means the equations can be written different ways. And still give you the same graph. And still make the same graph. I'm going to show you a shorter trick on how to graph equations. Okay? And this way, if we have a table of values or not, as long as we have the equation, it's going to be helpful. Now it's saying, take a try on this one and use the x values in the table to solve what y is going to be. What's a good strategy? Who do we need by itself? Who do we have to isolate? We have to isolate y, right? Because we have both letters, we have both variables. Whenever we're given both variables, we need to isolate the y variable. Okay? So I'll give you a couple minutes to try that on your own, and then we'll take it up together, okay? As you can see, we moved over the 6x first by making a zero pair. We subtracted 6 to both sides. We rewrote the equation. Now, when we rewrite the equation, does the 12 have to come first? Nope, we can put him second as long as his plus sign is in front of him, and the negative stays with the 6. Okay, we can rewrite them. Last step, always, we need to divide by the coefficient of the variable. We want y by himself, so you all divided by 3 to absolutely everything on both sides. So that means we have now an equation of y equals negative 2x plus 4. If you wrote it the other way, you would have y equals 4 minus 2x. They mean the same thing. Okay? And now we can graph him, and now we can figure out our table of values. Okay? So again, we're going to use our equation. 4 subtract 2 times the number. 4 subtract 2 times the number. 4 subtract 2 times the number. That's going to help us solve for the missing y numbers in our table of values. All right, I'm going to use my x numbers from my table in the brackets, negative 1, 1, and 3. Let's solve for y. Okay, let's take a look. We get 4, negative 2 times negative 1 is a positive 2. So 4 plus 2 is 6. We should have got 6 for that one. Over here, I've got 4 times negative 2 times 1 is a negative 2. We're going to get 2. 4 subtracting 2 times 3 is 6. So we get 4 subtract 6 is negative 2. So you should get 6, 2, negative 2. What do you notice they're doing? They're going down by 4. But is this side right here going up by 1s? No, what's it counting by? By 2s. So remember, if we were to find our pattern, we already have the equation, so we know the pattern. Okay, and the pattern always sits in front of x. They have a 2. Well, we got a 4 over here, and we have a 2 over here. How did they get this 2? They didn't double it. You always take the pattern here and do what? Divide by the pattern on the left. So they took 4 and divided by 2 to get that 2. They already gave us the equation. They don't have to figure it out. But that's how they did it. Okay? All right, so let's graph this guy now. So we're going to go left 1, up 6. Okay, left 1, up 6. Now we're going to go right 1, up 2. And then right 3, down 2. And again, yes, we join our points because we do not have a situation telling us not to. Okay, check your work. This one is talking to us and telling us how the heck are we going to graph something if we don't have a table of values though? Well, if we have the actual equation, we have to make sure that one variable is isolated. Okay? We have to make sure that the one variable is isolated. So usually if we have 2 variables, should we make it isolated? Always y. Okay. If it doesn't have it isolated, we need to isolate it. Okay? So what are the steps for isolating? Here they are on the bottom. Move x to the right side. Okay? To keep y on the left. How do we do it? We do it making 0 pairs. Okay, that's how we do it. Then it tells us to add like terms on both sides. And then we rewrite our equation. Then it says you move all the constants to the right and add like terms. And again, that's by making what? 0 pairs. So we move all the variables over, we move x over, leave y on the left, we move the constants over. Then we isolate the variable by dividing both sides of the equation by the coefficient, the number in front of y. Okay, that's super important. We have to be able to do that. And that's what we've been doing. Okay? So first of all, when we go to graph something now, if I have just a graph, let's put the graph on. If I have a graph on there, and it's telling me that I have an equation that says this: y equals 2x plus 1. Okay, 2x plus 1. Another strategy, if people got this isolated, but no table of values, you don't actually have to create a table of values. There's a strategy you can use, and it's called slope intercept. So if we use slope intercept method, it tells us how to move our dot. So our very first dot we use, the number in front of your x is what's called the slope. This one, like we know it's bossy, it tells us how to move the dot. Okay, how to move the point. Well, we need to know where our point is first. Where are we going to start? Well, we usually always start at 0, 0. But once we have an equation, we're actually going to start at the constant, wherever the constant tells us. So the number without the variable is where we start on the y-axis. Because if I cover up that x, what's left? A y equaling 1, correct? So that means that this is my start point. So your constant is always your start point. So then I would put a plus 1. Perfect. There's my start point. Then you move according to your slope. Now the slope you always want in a fraction. Okay, so put into fraction. So you can put any whole number into a fraction by doing what? Over 1. And remember, it's got that x beside it. The bottom number always moves to the right. Okay? It always moves right. The top number is going to go up or down depending on whether it's positive or negative. So this guy's a positive, so it's going to go up. If it was negative, it would go down. Okay, that's the top number of your slope. So right now it's telling me how to move by point. It says, okay, you're going to start at 1, and now you're going to move 1 right, 2 up, 1 right, 2 up, 1 right, 2 up. That's how I find my next points. So I'm going to go 1 right, 2 up, make my next point. 1 right, 2 up, make my next point. 1 right, 2 up, make my next point. So it kind of creates a staircase. And then you can join your points. Okay? That's an extension. We do more of that in grade 10. It's called slope intercept form that we do in grade 10. If you know it in grade 9, it makes grade 9 math and graphing much, much easier, which is why I introduced it to you now. Okay? It's everything we've been doing. Okay? But if you don't have a table of values, but only an equation, you don't have to always build a table of values. If you like to, go for it. If you're told to, you have to. Okay? But I would have got those exact same points if I would have created a table of values of x and y and made x equal to 0, 1, and 2. I would have found every single one of those points. Okay? This just did it for me a little quicker. Okay? Any confusion? Pretty good so far? All right, I'm going to draw another example up here. I want you to tell me which way the dot's going to move. Okay, here's another equation. We're going to graph that without a table of values. So you always start with the constant. That's where I tell you to start on the y line. So where do I start on this one? Positive 6. So I'm going to go make a dot on positive 6. And this tells me how to move my dots. So what does the bottom number tell me to do? 2 to the right. It always moves to the right. Okay, so I'm going to go 2 right. What does that negative 3 tell me to do? 3 down. So my pattern is 2 right, 3 down. 2 right, 3 down. 2 right, 3 down. And then I join my points. Okay? Good to go? So much easier? Good. That's why I show it to you, because it's easier to graph the points. Because sometimes table of values can get really confusing. Okay? And if you really dislike them and you find them confusing, refer back to this. Okay? All right, you know something from grade 10 now. Good job, you guys. Okay, let's move on. There's two other kinds of lines. We talked about the first kind. The first kind had x and y both in them. Now we're going to find ones that only have either x or only have either y in the actual equation. Okay? So let's graph each of these. We're going to graph each of those tables of values. Okay, I want you to find the points on the tables or on the graphs. I'll give you a minute to graph those. Okay. Write 3 down to, we're moving our dots. And whoopsie, they're on the spots. Let's write 3 down 2. Write 3 didn't go up or down, and then write 3 up 6. Okay, now we're going to join those dots. What kind of line did it create? A vertical line. Good, so we got a vertical line. So far we've only been dealing with diagonal lines. So vertical lines. So if that's a vertical line, what number does it touch on the x-axis? 3. What number do they only use for x? 3. So we call this an x equals 3 graph. Okay, vertical graphs are going to be x equals 3. All vertical graphs have to be x equals something. Always, always. No, not x equals 3, just x equals a number. Yes, sir. You just pick, if you graph x equals 3, you put a dot on exactly the 3 on x and then drop it down. So here's another example. If I say x equals -9, I'm going to count over to -9, make my point, and then I draw my graph up and down from there. Okay? So anything with x equals in front is always going to be a vertical graph. Okay? And it's always going to be a point that starts on the x-axis. Okay, so it says, what axis does it cross through? It crosses through which one? The x-axis. So that's why it's an x equals graph always. Okay, so always equation is x equals a number. Okay, it's always going to be x equals a number. Always, always true. Now, try the next one. You got a couple minutes to try this one. You go down to -4, 1, 2, 3, 4. I have -7 in -4. I have 1 in -4, and I've got 5 in -4. So what do we notice about these ones when I join their points? They make horizontal lines. Good, it's a horizontal line. And what axis did it cross? We could cross over. What's this axis called that's going up and down? It crossed the y-axis. So what do you think the equation has to start with then? Y. Good. How come? Which number repeated? The y number repeated. Good. So y equals -4 is our equation because the y number is repeated. So when you have y numbers repeat, they make horizontal lines, and you have a y equals equation. When you've got vertical lines and x repeats, you have a vertical line. Okay, it's the x equals equation. It's kind of opposite. So a good strategy to remember them is remembering the actual letters of the alphabet. So if I say to you, vertical line always starts with x equals. Well, what do you know about the letter x? It's got a V on top, and it's got a V that's underneath, right? A V that's upside down. So an x is made from 2 V's. Does that make sense? So that's a way to remember that it's vertical. It's a vertical line. So an x equals a number is a vertical line going up and down because it's made from 2 letter V's. That's a good way to remember it. The y, if I create the y number and write y like this, that looks like an upside down what? H. Looks like an upside down H. Well, y equations are what kind of lines? Horizontal lines. Good. So a good way to remember that is that the y is an upside down H. Okay? So horizontal lines are y equals numbers. Okay, a little better? Perfect. Couple more things here. So, conclusion. We just wrote our conclusion on the last page. That if we have a y equals, what are we going to have? What kind of line? Horizontal. Because the y is an upside down h. If we have an x equals equation, it's going to be vertical. Okay. This question saying we have a rectangle on our graph. It wants the equations of our lines that made the rectangle. So if I outline this, I'll outline this for you. I've got a vertical line going here, and I've got a vertical line going there. So that means I'm going to have two vertical equations. My vertical line equations are going to start with which? X. So I know this one right here is going to be an x equals line, and this one's going to be an x equals line. So now I want you to count where they ended up on x. What number would they be? What lines would they be? Okay, so we should get x equals, that was 8. Okay, and what's this one? X equals 5. Okay. -8. Thank you. You're right. It's a negative there. Now we've got a couple horizontal lines as well we have to draw. So I have a horizontal line here, and I have a horizontal line here. So what numbers do those cross on? And what kind of equation will those give us? Y equal lines, good, because they're horizontals. And what y numbers do they touch? 5 and -2. How do you know? What you do is you find out what number it touches on that axis. That's how you know. So I would look at that number, and I would look at that number, and I would see what numbers they are. That's what you know the equation is going to become. Okay? Any confusion with that? Last couple questions. We want to graph y equals 6. Y equals 6, first of all, what kind of line is it going to be? Diagonal, horizontal, vertical? Horizontal, nice. So I'm going to go up 1, 2, 3, 4, 5, 6. And I'm going to go left and right on number 6, okay? You are correct. It is a horizontal line. Okay, it's repeating the number 6. All right. The bottom one says x is -2. So I'm going to count left to -2 and then draw up and down to make my line. Okay? And that one's going to be my vertical line. Let's answer the last couple questions. Some linear equations have x and y. Here are a couple examples. 2x plus 3 equals y. I could have 5x minus 4y equals 10. Okay, those are ones with x and y. And we call those ones diagonal. Now we have a new word for diagonal in math. It's called oblique. So oblique is another word for diagonal. It's a fancy math word. So then we have equations with only a y and no x. So if it's y equals 4, y equals -100. What kind of lines do we make with y ones? Horizontals, because y is an upside down h. So we made horizontal lines. Then we've got ones with x and no y's. So x equals 7, x equals -17. Those are going to become what kind of lines? Vertical lines. Nice. So we learned how to graph 3 different types of lines, and we learned how to graph them without tables of values. This concludes lesson 5.3 of graphing different types of linear equations.